Hey guys, today we're going to talk about a different perspective of prisms, and we're going to talk about surface area. So this is lesson 10-3, surface area of I have to do this weird, rectangular prisms. Oops, oh, hello, prisms. And today's date is 4/29/19. Okay, so you can see I'm using graph paper, which means I'm going to be drawing on this one. So let's talk about what on earth do I mean by surface area. So again, a lot of vocab when it comes to geometry. So surface area is the sum of the areas of all of a three-dimensional figures, faces, or surfaces. Okay, so that's where the idea of surface area, because I guess face area sounded kind of funny. So let's go ahead and draw a rectangular prism. See, I knew that was going to be weird. That's better. There we go. Okay, so put in my Superman vision. And we're going to add some numbers here. 4 inches, 2 inches, and 3 inches. So again, we're talking about a rectangular prism today. We'll talk about triangular prism in another set of notes. The surface area of. So a couple interesting things about a rectangular prism. First, there are 6 faces, which means I need to have 6 areas to figure out the whole surface area. Now what's interesting is that we do have some matching areas on all rectangular prisms. Okay? In fact, since we have 3 unique dimensions, a length, a width, and a height, that leads to 3 unique areas. Now, there's always exceptions. We could have 2 of the dimensions have the same number, or all 3 if it was a cube. But when I'm talking about unique dimensions, I have a length, a width, and a height. Okay, so keep that in mind. Now, I mentioned this last week, is the term net, and I'm pretty sure you guys should have covered this. I'll have to go back and study what happened in 5th grade, but it is a 2-dimensional, and I remember one class somebody did an amazing job with this definition. 2-dimensional representation of a 3-dimensional figure. So we're basically flattening out the shape, and that diagram of what the shape is in its individual pieces as they are attached to each other is called a net. What's great about a net is it helps you visualize or see all faces of a figure so you can calculate the area of each face more easily. Okay, so that's what a net is. So let's draw a picture of the net from before. I'm going to do it in a slightly darker color. So we've got a 1, 2, 3, 4, 1, 2, 3. So that is the front. That's the shape we saw at the front of our guy. And so this is 4 inches. And this is 3 inches. Okay. And then we can shift over to the top. And the top is also a 4, but this time it's only by 2. So this is your top. So 4 inches by 2 inches. Okay. And then we have to get to the back. So it's going to be exactly the same as the front. So we have 4 inches and 3 inches. And then the opposite of the top is the bottom. So he's going to match exactly the top. So 4 inches and 2 inches. And then off of the top, we can put our sides in. And they are 3 by 2, so 3 by 2. So we have a side, we have a side. Oops, I don't know where that came from. Let's try that again, huh? So this is a 3 inch by 2 inch and a 3 inch by 2 inch. Okay, so our 3 unique dimensions were 4 by 3 by 2. And what I need to do is come up with the 3 unique ways to multiply those numbers. And unique means switching the order is not going to be something new. So for example, we do have a 4 by 3. So 4 by 3 went with the front and the back. Okay. So the area is 4 times 3, which equals 12. Okay, now, because the front is an area of 12 and the back is the area of 12, remember, you have 2 of them. So the area for the both of them isn't 12. The area for one of them is 12, so the both of them would be 24. All right, another way that I can arrange those values would be doing a 4 by 2. 4 by 2 goes with the top and the back. So the area of the top, let's say, is 4 times 2 is 8. But remember, the back is the same, so we're going to get 2 of them. So instead of the area just being 8, it's going to be a total of 16, right? And then we've got the sides, and that would be putting together 4 by, or nope, sorry, no 4s. We've already done all the 4s that we can possibly do. So then let's see, what's left is a 3 by 2. And that's going to be side 1 and side, or the 2 sides. So I'm just going to say left side, right side. And the area is going to be 3 times 2, or 6. But remember, that's just for one of them. We have 2 of them. So if you want to add this up, we end up with, let's see, 26, but we have to double that, and we're going to get 52, and this would be square inches. And I was a naughty girl and didn't write in labels here. All of these have labels of square inches. Okay? So that's one way to do this. The other way is to recognize we have a front and a back. the area is going to be 4 times 3, but I'm going to get 2 of them. In fact, I'm going to color that different so it stands out. And so we're going to end up with 2 and we're going to multiply it by 12. So for this first round, I'm going to get an area of 24. So this is a different way of solving the problem. And then again, that would be square inches. And then if I did the top and the bottom, or top and bottom, I would get 2 of them. And their area would be, for each one of them, would be a 4 by 2. So that's going to give me 2 times 8, which equals 16 square inches. And then last would be the 2 different sides. So I'm going to say left side, right side. So I'm talking about 2 different sides with an area of it's a 3 by 2, which gives me 2 sides that measure 6 for a grand total of 12 square inches. And then all I would do to figure out the surface area is add these up, which would give me a grand total of 52 square inches. Okay, so let me go back. I'm going to add that over here. Surface area equals. Okay, so again, 2 different ways to do this. Pretty easy. 3 ways, just looking at the ways that I put the 3 dimensions together. So it's going to just work however you see it. Okay, let's do 2 examples, and one will be given to you as a net, and one will be given to you as a regular 3-dimensional shape, and you get to decide how you want to solve these. So directions are going to say, find the surface area of each rectangular prism. Okay, so we're going to draw this guy out. Let's see. 1, 2, 3, 4, 5, 6. Oops, that's not going to work. I'm going to, you know what? I don't need to be realistic. Just make it look like this. So this is 7 meters by 6 meters. Okay. And we're going to say this is 6 meters by 8 meters. And this guy, we're going to have to figure out. And this guy is going to be 8 meters by 6 meters. Oh, that looks terrible, doesn't that? All right, you know what? Scratch it. I'm going to do it all over again. Sorry. Okay, let's see if I can do this again. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Nope, that's not big enough. I got to go down further. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Let me double. 1, 2, 3, 4, 5, 6. Okay. Doing a life-size one. So this is the 7 meters by 6 meters. The reason why I'm doing this because I want you to see something that happens. 4, 5, 6, 7, 8. So this is 6 meters, but or actually let's put them on the outside. And this surface is 8 meters. Then we have this guy. And then we have this guy. 1, 2, 3, 4, 5, 6, 7, 8. I know that was 6. Oy, 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 oy. 1, 2, 3, 4, 5, 6. Now that looks like that. And that's, again, 8 meters at the bottom, 6 meters on this side. So here's what I want you to understand, and I'm going to kind of highlight it over here. This is 6. If I fold it up, this guy right here, this is going to match him perfectly. Okay? So when I fold up, those sides that are next to each other are going to fold up and touch each other, and they should be the same length. So there you go. All right, this guy. Let's keep going. So let's see. 1, 2, 3, 4, 5, 6, 7. Boom, 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 boom. So 6 meters is here. So again, that relationship that I just pointed out at the bottom exists here on the side. It also exists here. And guess what? It exists here. So that's how we get the box to match up. Okay? And then this one, we've got 1, 2, 3, 4, 5, 6, 7, 8. And just to let you know, these notes should be 2 pages with the example on the second page. Okay? So this guy is an 8 meter by 7 meters. Okay? So what we're going to do is look at the areas of these guys, and I'll kind of color code them a little bit. So this guy is a 7 by 6 rectangle, and he has a partner, and that partner is over here. So when I fold up my shape, those two sides would be opposite and parallel to each other. So he's also 7 by 6. And then we've got this guy, and he's the 8 by 6. And he has a partner over across. So when they fold up, they're facing each other, and also 8 by 6. And then we have just these guys. Come here. The colors didn't want to show up. This guy and this guy. And his dimensions are 8 by 7 and 8 by 7. Okay? So looking over here, oh, that color is not the same one, is it? It's a lighter pink. There you go. That's the one. So we had 2 rectangles, and they were 7 by 6. So I'm going to multiply once and double it, and we get 84 square inches. Okay, and then let's look at the yellow ones. And the dimensions of those guys was 8 by 6, which equals 48, and we have 2 of them. So that's 96 square inches. And then last, Come on. There we go. And that guy was an 8 by 7, which is 56, but we had 2 of them, so this is going to give me 112 square inches. Oh no, did I do that right? Oh, yep, I did. Okay, sorry. Brain freeze, too late. Need to go to bed. So let's add up. We got 10, we've got 12, we got 10, 19, we got 292 square inches is the surface area. Oops, almost spelled it correctly. Oh boy, what is my deal today? Hello. Of this particular rectangular prism. Okay, well, I'm going to show you the second way over here in the right hand corner. We're going to do number 2. Now this is not going to be true to measurement. I'm just going to draw it out. We're just going to have to trust that I can actually do this without being too dopey. Okay, so this is a 7 centimeter by 5 centimeter by 3 centimeter shape. So here's the numbers you need to focus in on. 7, 5, 3. Now if I wanted to do volume, I would multiply them, but I'm not doing volume, I'm doing surface area. So what we're going to do is we're going to take the first 2 numbers, we're going to multiply them. Now that represents the bottom and the top, the 7 by 5. So that's going to give me 35, but 2 of them are going to give me 70 square centimeters. A lot easier if you can get this pattern down. Next, we're going to look at the next 2 dimensions. Let's do 7 and 3. So 7 times 3, and if you look at 7 and 3 is the front. We can do it this way. Boop. There's your 3, and there's your 7. Okay, so that's 21 times 2, which is 42 squared centimeters. Okay, and last but not least, we're going to pair up the 5 and the 3. This is the only way that we can take 3 numbers and put them together. So the product is 15, but we've got 2 of them, so that gives me 30 squared centimeters. And then all we do is add them up for surface area. So surface area is equal to the sum. We get a 2, we get a 10, and a 4 is a 14. So we get surface area is 142 squared centimeters. Sorry about my lousy drawing tonight, guys. All right, we'll talk to you tomorrow about this. Bye.